what you see is a conventional switchboard. This is the back side of the board. So this is a 8 switchboard with the 2 sockets. Now we are going to wire it. Now what this you can see is a loop phase wire, which is generally looped along all the switches to provide the phase to all the switches. These are different load wires which are connected for each switch. So these load wire actually go to your equipments. It might be your fan, lights, or anything in. This is a phase that is coming from the meter or somewhere from centrally from you. This is the loop. This is the back front side where you see the switches, where if you turn on the switch, a particular phase will be routed to a particular equipment through these wires. Okay, this is a tape here. We're going to use it to name these or tag these wires. You can see here, this is wire 1, this is load 2, this is load 3, load 4, likewise. We also tag this phase wire so that you can remember it. It's a phase in. So just name it phase in. This is P in, which is phase in. This is all AC arrangement, which is already there. Now this is a device. On this device, you can see these are 8 plus 2 ports. These ports are for loads, AC loads. These 2 ports are for phase and neutral. This is the back side of the board where these are different wires. These are 2 plus and minus wires, red plus, black minus. This is for 5 volt supply. These are input switches detection wires, which we will tell you later on. So this is what about the device. Now back to the switchboard. Now what we need to do over here is to remove the entire AC from the board. We also remove the load and attach it to the board. So each and every load will remove from the switchboard and attach it to the device board. So for example, load 1 will be attached at the point 1, load 2 will be attached at the point 2. We'll do it one by one. Now this is the load 1, we'll remove it. And put it on the output port of the device. This is the AC port of the device. We'll put it at the port 1, which is meant for load 1. Now this relation can be changed also, or it can be kept as it is also. Now here we want to turn on the load 1 by switch 1. So that's why we are doing it in a sequence. So now this is load 2, and we are putting it back in the device AC port 2. Likewise, we'll make an arrangement for all these 4. Now we are showing you only 4 for simplicity, but you need to attach all the 8 ports or 8 switches to the 8 ports. So we have done this L1, L2, L3 and L4. I hope this is clear. Now AC coming from the device will be given to the loads, respective loads. Now it's time to use this AC phasing. Now we don't want any AC on the board, so we'll disconnect this phase. We'll keep the loop so that we can use the loop for different purpose. Now we'll removing this AC. Now you can use this AC or any other phase, AC phase, to give it to the device. Now device needs an AC in, which are these 2 points where right hand side is a phase in. You can see here we are attaching this phase in wire to the device phase in, and left hand side is a neutral. So you can use any neutral that is coming into the switchboard. Mostly we have one neutral coming from various points from your homes. That neutral actually runs in entire house. So we are using one of that neutral wire to give a neutral in to your device. Our device has got AC, so that this AC later can be routed to different loads. So You can see here, this is how we attach. Now back to the device DC part. Now these are two wires which is used to power the board. So we are using this external module. You can simply identify plus and minus wire, red and black or red and green. So in this case we have red and green. Red should be attached to red, which will be plus 5 volt. Another will be plus minus 5 volt, or we can call it ground. So we are powering the board now. This is all disconnected, so we're just making wires. Make sure to tape it properly with the proper electrical tape, good quality electrical tape. This is all going to be inside the board, so make sure you do it properly. We have plugged the power supply, or connected the power supply at least. Now we have these 9 wires. Out of these, the first wire always will be DC phase. Basically these are all 3.3 volt wires. So first one is a DC phase. We will use it to route on the switchboard. All rest of these 8 wires are for 8 switches from the switchboard. So now what we are going to use this DC phase. We'll also name all of these wires correspondingly with again the same tagging we used earlier. So now we have named this. First wire is a phase DC, so DC phase, then S1, S2, S3, S4 up to S8. So all these are input for switches. So now we'll be using same switchboard without any AC. There will only be DC on this switchboard. Remember again, there won't be any AC near to this switchboard. We are connecting this phase where earlier there was AC phase, now there will be a DC phase. This will be just 3.3 volt of DC which is coming out from the device. Let's connect it back there. We have kept the loop as you can use a different loop, a different cable for the loop, or some different wire for looping, but as for simplicity we are using the existing. Now this is the first switch S1 and a cable S1. So we are using the same switch from the switchboard where L1 was there, load 1 was there, to connect S1 there. Again, as I already told you, this sequence can be changed if you want, but remember that if you attach a different wire to these switches, switch 1 will be controlling a different light at the output of the device. So now we are connecting S2 at the second switch position. So for example, if we connect S4 at first switch, then first switch will be controlling load 4. We'll do it for other also. So for now we are connecting all the cables in the same sequence that were earlier for AC loads. We'll keep aside the rest of the S5 to S8. We need to connect it, but for now, for simplicity, we'll avoid that. So this is complete now. Now this board is ready to be inserted back into the switchboard position. You can keep the device inside, put the back of this, put the plate back to the its position. Just for a review purpose, let's take a review of all the things that we have done from the beginning. The first thing, the AC part, we have connected AC, we removed it from the board, connected AC phase neutral, attach respective load to the output of the device or AC load part of the device where all these terminal blocks are there. Keep the sequence same if you want to be same. These are all nodes. Then is a power supply, a DC power supply, plus minus, red plus and black ground. all input switches wire. The first wire is a phase or DC phase, which is going to the switchboard to loop around all the switches. Rest of the 8 switch wires or input wires, which are connected at the same respective positions like S4, S3, S2 and S1. We have not connected for now all other 4 wires. We have connected S1, S2, S3, S4, the position where there was load 1, load 2, load 3. Now the board is entirely ready. You can put the board back. That's it. Thank you very much. In the next part, we'll be using Wi-Fi configuration. I will be showing you how to configure the board after powering up. Thank you very much.